beautiful listeners, welcome again to class. It is your favorite channel, Jeff Nino Mathematics class, and today we are going to be looking at the continuation from our last video, which has to do with matrix and determinants revision. Alright, in our last video we talked about addition and subtraction of matrices, multiplication of matrices, and also transposition of matrices. But in this video, I'll be teaching how we can be solving problems on determinants of matrices, minors and cofactors of matrices. Alright, if this is the first time joining us, you're welcome. Please don't forget to subscribe and also help us share our videos so that other students can learn from this amazing class. Okay, now the first one we're going to be looking at today is the determinants of matrix. And we are going to be looking at it under two categories, which are 2 by 2 and 3 by 3. Alright, so we are going to be finding the determinants of 2 by 2 matrix, and also we are going to be finding the determinants of 3 by 3 matrix. Alright, so let us begin with the smaller, which has to do with the 2 by 2, and then we go to the 3 by 3 matrix determinants. Let's begin the class. First of all, determinants can be represented with this sign, or you can simply say DET. So if I should say this, it simply means the determinants of A. Or if I should say DETA, it simply means that A, which is determinant of A. So any of these two means determinants. So let's solve some questions. Example number 1 for today. It says if, okay, A is equal to 4, 3, 1, 2. Find. Alright, don't forget I said this symbol means determinant of A. And this is a 2 by 2 matrix. So how do you solve the determinant of a 2 by 2 matrix? It is very easy. Solution. Now determinant of A becomes, watch this. You multiply 4 by 2 minus 3, you multiply 3 by 1. That is how you solve 2 by 2 determinants. So now 4 times 2 gives us 8, minus 1 times 3 gives us 3, and 8 minus 3 gives us 5. That is our answer. It is as simple as that. 8 minus 3 gives us 5. Don't forget to subtract, right? 8 minus 3 gives us 5. That is how you solve 2 by 2 determinants. But sometimes the question might look like this. Let's see. Example 2. Okay, imagine a question looking like this. If, watch, x 1 4 2 equal to 10. Find the value of x. Imagine you have a question that looks like this. We should find the value of x. How do you solve problems like this? It is very easy. First of all, you will notice that the sign here is the determinant sign I told you about. So here, we are going to look for the determinant here. And what we get here, we're going to equate it to 10. So let's go. Now, how did I say you solve for determinants? This times this minus this times this. Simple. Now, x times 2 will give us what? 2x. Minus, don't forget that. 4 times 1 gives us 4. Equal to what do we have here, class? 10. So now, we all know that 4 cannot be subtracted from 2x because why? 4 and 2x are unlike terms. 4 is not carrying x. So what do? We'll collect like terms. Minus 4 goes to the right hand side of the equation and becomes a positive 4, which is plus 4. So here becomes 2x is equal to 10 plus 4. Now, 2x is equal to 10 plus 4 gives us 14. Now, we are looking for the value of x, which is not standing alone because of 2. So what do? We divide both sides by 2. Class, when 2 cancel out, so what do I have? X is equal to 7. 14 divided by 2 gives us 7. That becomes our answer for the value of x. For you to cross-check, whenever we have x, let us put the value of 7 there. Let's see. 7 times 2 gives us 14 minus 1 times 4 gives us 4. When you minus 4 from 14, we are going to get the value 10. Simple as that. Again, what if the question looks like this? Which takes us to example 3. What if the question looks like this? If y 4, 1, 3 is equal to 1, 2, 1, 4. The question says find y. How do we solve this kind of question? Again, very simple. Like I said, this is the determinant sign. So what do? We look for the determinants of this matrix, and we also look for the determinants of this matrix, and then we equate it together. So let's y times 3 gives us 3y, minus 1 times 4 gives us 4. Are we there? Now 1 times 4 gives us 4, minus 1 times 2 gives us 2. So what do? Here becomes 3y minus 4 is equal to 2. But don't forget that minus 4 cannot be subtracted. 4 cannot be subtracted from 3y because they are non-like things. So if minus 4 comes to the other side, it becomes plus 4. So here becomes 3y is equal to 2 plus 4. 3y is equal to 6. And of course, we are looking for the value of y, which means we have to divide both sides by 3. Which is the coefficient of y. So when 3 cancel out, what do we have? Y is equal to 2. Simple as that. Simple as that. So this is how you can solve problems on 2 by 2 determinants. So let's move to the other part of our teaching for today, which has to do with 3 by 3 determinants. All right. 3 by 3 determinants. Now in this video, I will be teaching you 2 methods for solving 3 by 3 determinants. 2 methods for solving 3 by 3 determinants. So let's see the first question for today. Example 4. It says, evaluate 1, 2, 1, 3, 1, 2, 4, 1, 3. That's the question. 1, 2, 1, 3, 1, 2, 4, 1. 1, 2, 1, 3, 1, 2, 4, 1, 3. How do we solve? Here we can use minors in solving this problem, which is the method 1 I'll be teaching you. So let's go. Solution. Now according to cofactors, these elements here has signs that you really can't see. So when you are looking for the determinants of 3 by 3, you have to bring out the signs. But since we want to use just this first row, we don't need to bring out the signs of the other parts. We just bring out the sign of the first row. But if you are using the second row, you have to bring out the signs for the second row. First of all, what are the signs? This. The first sign here is plus, second sign is minus, third sign is plus. The sign here is minus, plus, minus, and here is plus, minus, plus. These are cofactors. When you add signs to minus, they are cofactors. We have not gotten there. We have not gotten there. But because we in this question, I want to be using only row 1 as our case study. It means we are going to be using only the sign. Right? There is no need for the other signs. We will only make use of this sign if we are using what? Row 2. And we only make use of this sign if we are making use of what? Row 3. So don't forget that. So let's see now. If we should inscribe these signs into row 1, we're going to be having this plus, minus, and plus. Alright, because we are using row 1. Plus, minus, and plus. So let's begin the class. This is how we solve. My first element here is 1. I'll bring it out. 1. Are we there? 1. Now, I will write nothing here. I'll write nothing here. I will omit this and this. I will omit the elements on that one. Every element on that one, I won't write. So the remaining element, which is this 4, is what I'll put here. So here becomes, what do we have there now? 1, 2, 1, and 3. Good! Simple. Now, let's go to the next element. What do we have now? Not just 2, but minus 2. So here it comes. Minus 2. I open again. Write nothing under what? Minus 2. Write nothing under, beside minus 2. What are we going to write now? The remaining 4 elements, which are what? 3, 2, 4, and 3. 3, 2, 4, and 3. Then we close. What is our last element here now? Plus 1. Alright, plus 1. So without wasting time, we're going to be having this. When we write plus 1, 2, 3 we won't write. 1, 2 we won't write. So what are we writing now? 3, 1, 4, 1. Yes! Simple. So this is 2 by 2 determinant, 2 by 2 determinant, 2 by 2 determinant. So in a 3 by 3 determinant, you can find the 2 by 2 determinant in it. So here becomes 1. Again, how did we solve 2 by 2 determinant? This multiplied by this, minus this multiplied by this. Now 1 times 3 gives us 3, minus 2 times 1 gives us 2. Then minus 2 into bracket, 3 times 3 gives us 9, 4 times 2 gives us 8, plus 1 into bracket. 3 times 1 gives us 3, 4 times 1 gives us 4. Simple, simple, very simple. Now let's work with the brackets. Here becomes 1 into bracket, 3 minus 2 gives us 1, minus 2 into bracket, 9 minus 8 gives us 1, plus 1 into bracket, 3 minus 4 gives us minus 1. Right. So let's open the bracket now. 1 times 1 gives us 1, 2 times 1 gives us 2, plus times minus gives us minus, and 1 times 1 gives us 1. So class, what do we do? Let's work. 1 minus 2 gives us minus 1. Minus 1 minus 1 gives us what? Minus 2. So the determinant of this matrix is minus 2. Simple as this. Simple as this. But don't forget I told you we're going to be using two methods in solving this question. This is actually method 1. So let's go class now to method 2. Method 2. Let's see. Method 2. Now method 2 has nothing to do with minors. It has nothing to do with the signs here. Nothing. No relationship. Nothing. You don't need those signs at all. What you just have to do is this. Please watch me. What you just have to do is this. In the original question, I have 3 columns. But what you are going to do now is that these first 2 columns, you will add this here again. The first 2 columns, you write it here. So it means we are not going to be having 5 columns instead of 3 columns. Let's see. Solution. Let's write the original ones. We have 1, 2, 1, 3, 1, 2, 4, 1, 3. This is the original element. So what did I say we'll do? The first column is 1, 3, 4. Write it again. The second column is 2, 1, 1. And then you close. Only the first. Don't repeat the first, the third. Only the first. So what do you do now? Watch. You start multiplying diagonally. 3, 3, 3. Now, why did I not multiply this? Although they are diagonal, but they are not how many? 3. They are just 2. So it's not 3 elements. So let's do now. 1 times 1, 1. 1 times 2, this means 3. Plus 2 times 2, 4. 4 times 4, this means 16. Plus 1 times 3, 3. 3 times 1 gives us 3. We are done with the first one. We'll now say minus. You open another one again. Now from the right hand side, you come back. So what's my first 3 here now? 2, 2, 3. So 2 times 3 gives me 6. 6 times 3 gives me 18. Plus 1 times 2 gives me 2. 2 times 1 gives me 2. Plus 1 times 1 times 4 gives me 4. Aha! So let's see. 3 plus 16 gives me 19, and 19 plus 3 gives me 20. Sorry, 19 plus 3 gives what? 22. Good. Minus 18 plus 2 gives me what? 20, and 20 plus 2. 20 plus 4 gives me what? 24. Now, what is 22 minus 24? Minus 2. Which was the same answer we got when we used the minor pattern in solving the same question. So you see, when that one fail you, this one should not fail you. When this one fail you, that one should be available. Very, very important. It is very important. Alright. So class, this is how you solve problems on 3 by 3 determinants. 3 by 3 determinants. Like I said, we're going to be solving determinants, minors, and cofactors. Determinants, minors, and cofactors. Alright. So what we're going to be doing now, we are done with determinants. Let's go to minors. How do you solve minors and cofactors of matrices? Minors and cofactors of matrices. Alright? Let's begin. If you are just joining us, you are welcome to class again. Please don't forget to subscribe. Please don't forget to put on your notification bell so that when I give videos, you'll be among the first students to get notified. And then you can continue to learn from the comfort of your home. Alright, in the comfort of your home. You can also leave comments on the comment section so that we know how you felt about the class. Alright, let's go. Minors and cofactors. Minors and cofactors. Okay. Let's see. Imagine you are given a question like this. 1, 4, 2, 3, 1, 3, 2, 1, 2. Class, please go. Imagine I'm doing a question like this. And then we are told to find the minors and also the cofactors. How do you go about it? First of all, cofactors are minors with ascribed signs. You see the sign I gave before, your plus, minus, plus, minus, plus, minus, plus, minus, plus. When these signs are allocated to the answers of minors, they become cofactors. They become what? Cofactors. So when these signs are not there, they are not yet cofactors. So let's go. Let's begin the class. First of all, how do we find the minors? Here, 1 here represents M11, which is our minor 1, 1. 4 here represents M12, M13. M21, M22, M23. M31, M32, M33. Where M there represents what? Minors. Good. So let's go now. What's our first number here now? 1. So I'll be my 1. I'll be my 1. And then what do we do next? We will omit these elements here beside 1 and below 1. So what we have here now are what now? 1, 3, 1, and 2. Okay. Now next, 4. The numbers beside 4 don't write. The number below 4 don't write. What are the other elements now? 3, 3, 2, and 2. Stop. Next one, 2. The number beside 2 don't write. The number below 2 don't write. What do we write now? Here becomes 3, 1, 2, and 1. These are our what? M11, M2, M12, and M13. Let's go to the next one. The next one now we have now is what? 3. We'll write it out. When you are working with 3, these two numbers you don't write. These two numbers you don't write. So what do we write? 4, 2, 1, 2. So here becomes 4, 2, 1, and 2. Now we have 1. So if I don't write here and I don't write here, here becomes 1, 2, 2, 2. Next number becomes 3. If I don't write here and I don't write here, it becomes 1, 4, 2, 1. Good. And lastly, what do we have? 2. If I don't write here and I don't write here, what do I write now? 4, 2, 1, 3. Now I have 1. If I don't write here and I don't write here, what do I write? 1, 2, 3, 3. And lastly, what do I have? 2. When I don't write here and I don't write here, what do I have? 1, 4, 3, 1. Okay. Now, this is what we are going to do. One multiplied by 2 gives me what? 2. And 3 multiplied by 1 gives me what? 1. So what do I have here now? I have 2 minus 3. Here I have 3 multiplied by 2 gives me 6. 3 multiplied by 2 also gives me 6. What do I have? 6 minus 6. Here, 3 multiplied by 1 gives me what? What's it called? 3. And 1 multiplied by 2 gives me what? 2. What do I have? 3 minus 2. Okay, now what do I have here now? Here becomes 4 multiplied by 2 gives me what? 8. Minus 1 multiplied by 2 gives me what? 2. Also here, 1 multiplied by 2 gives me what? 2. And 2 multiplied by 2 gives me what? 4. Now, 2 multiplied by 4 gives me 8. 1 multiplied by 1 minus 1. And then what do I have? 4 multiplied by 3 gives me what? 12. Minus 1 multiplied by 2 gives me 2. Again, 1 multiplied by 3 gives me 3. Minus 2 multiplied by 3 gives me 6. And lastly, 1 multiplied by 1 gives me 1. And then 4 multiplied by 3 gives me what? 12. Alright. Now, without wasting time, 2 minus 3 gives me minus 1. 6 minus 6 gives me 0. 3 minus 2 gives me 1. 8 minus 2 gives me 6. 2 minus 4 gives me minus 2. 8 minus 1 gives me 7. 12 minus 2 gives me 10. 3 minus 6 gives me minus 3. And 1 minus 12 gives me minus 11. Now, don't forget that when we are looking for cofactors, this is our minor. When we are looking for cofactors, what are we now going to do? We are going to assign the signs to these values. So when we do that, here becomes plus, minus, plus, minus, plus, minus, plus, minus, plus. Now let's work with that. Here it becomes. Now plus times minus is still minus. So I have minus 1. Here is also 0. Here is also 1. Here will now be minus 6. Here will now be minus 2. Because plus times minus gives you minus. Here becomes minus 7. Here becomes 10. Here minus times minus that gives us plus. So here becomes 3. And here becomes minus 11. This becomes our cofactor. This becomes our cofactor. So you see, for us to get cofactor, you need to first get minus. Because after you've gotten your minus, you have signed the signs, then you've got your what? Your cofactor. So see in class, we have come to the end of today's video, which has to do with determinants of matrices and also looking for the minors and cofactors of a given matrix. I believe you enjoyed today's class. Until we meet again in our next class, keep watching BFN112 mathematics class and also keep helping us to share our videos. Till we meet again in our next class. Bye for now.